we just got introduced to the idea or the existence of charges. Now is how can we make use of that? Like water, wherein we store it at one point and we open the tap to get the water, or make it flow through a path and generate electricity per se. Here too, we can have charges stored at one place, open the tap, that is switch on the switch, make it flow through different devices, light, that is a bulb, a fan, a motor, so on and so forth, and get some work done out of it. That's the whole funda. That's all we're trying to do. The entire idea is just that. Keep the charge at one point, accumulate it at one end, store it at one end, open the tap and make use of that. But before that, before making use of it, we need to understand how to get it to one place, get all the unlike charges at one place, right? We have seen that unlike charges ripple, is it not? Now we are trying to get it at one place. How can we do that? One of the method is electrostatic induction. Electrostatic induction. In electrostatic induction, it's all about moving things, in this case electrons, without touching them. You have heard the word induction somewhere, right? Try to link everything. So electrostatic induction is about moving electrons without actually touching them. Now, let's explain it this way. Let me explain it this way. So we have figure A and B over here. Say we have a neutral charge. Okay, you have an electron or a atom, sorry. We have an atom which is not exposed to any uneven electromagnetic field. Okay, so basically the charge would be spreading out in this way. That is, the proton will be at the center itself, while the electrons are the one which is moving around. It will move around in such a way that the aggregate is at the center. Okay, so it's moving around in such a way that it's within this sphere, in this circular structure, averaging to middle of it. What if we get some positive, in this case, sorry, negative charge over here or a positive charge over here to the same thing? What happens? If in case of a non-conducting material, there is a high chances that the electrons will spend more time onto the left than on the right. Will get pushed to the left, more, a lot more to the left compared to the right. Now, if we take the aggregate, the negative charge can be imagined to be away from the positive charge. There's no overlapping. Here, the positive and the negative, the average of things used to overlap. Here, it's not. So here it is a lot negative to the left and lot positive to the right. This is how they spread out. Okay, this is one of the possibilities of electrons spreading out. That is, they'll be roaming around the space, just that the space will be a lot more to the left. So the official definition of electromagnetic induction is the following. It's a process wherein we have a charged object, right? Like this over here. This is your charged object, CO. Charged object. Charged object creates a charge separation, right? Like over here in a neutral object by bringing it closer without physical contact. So this is your neutral. Figure A gives you guys your neutral scenario. And when we get a charge, that is case B, we have it redistribution this way. This redistribution of charges results in opposite charges being induced on the near and far side of the neutral object. One more example is, say we have a wall or any insulating material. We get a charged object near that. The atoms will rearrange in this way. The electrons will start moving in such a way that it's more negative to the left. Okay, guys. So again, remember, we are trying to charge things without actually touching them. Now, we didn't actually study how we are doing it. I mean, we understood the phenomena that the electrons will basically spend more time to the left or the right depending on what kind of conducting or charged material we have it near, right? Now, exactly how can we do this? Well, we have two examples over here. Making use of two spheres connected to, say, these are two spheres. These are good conductors and these are your bad conductors. Okay, these are bad conductors of electricity. So these are touching each other. Now, if I get a charged material, say this is negatively charged material, what happens? Obviously, the electrons will run away to this end. It will accumulate more to the right end, leaving behind a lot positively charged things on the left end, right? Because of the absence of electrons, or some of the electrons, not all of course, this will be positively charged, this end, while on the right end it is negatively charged. Now what can we do? The smart thing that we can do is we can just pull it off. We can separate A and B. There's no connection. So what will happen? The charge will redistribute over here and we have the object to be negatively charged. Okay. Now, if I move the rod away, as in diagram 4, what will happen? A and B will be positive and negatively charged. Make sense? So this is one of the ways. Next, we have charging a sphere by induction. We have sphere, we have a neutral object over here. Negative and positive charges are even over here. So this is a neutral object. We get a negatively charged material near to the sphere. What happens? The electrons will run away, making this end positive. Of course, there need not be this drastic movement. Actually, it can be, depends on the material. So there will be more positive charges on the right hand. So basically, less electrons on the right hand, more electrons on the left hand. Now, if we can do a smart thing by connecting the end to the ground, what happens? The electrons will run away because they want to move away as far as possible from this particular rod. So which is the best place? Further than this will be ground, right? They'll go to the ground. Now, if we remove all of this, while keeping the rod, if I remove the connected wire, what happens? If I remove the rod as well, the sphere will be positively charged. So what did we do over here? We're looking at accumulated positive charge over here. And we are looking at accumulated positive and negative charges over here. So without actually touching anything, we are able to charge two object or one object and thus accumulating the charges. That's what we have to do, right? Once we have the accumulated charges, then connect it to a bulb and you have your light, is it not? So electromagnetic induction is a process wherein we are charging an object without actually touching it, right guys? So my suggestion is you guys can copy the definition, and on those two experiments don't copy the write-up because it's just a description of whatever we discussed. So diagram, if you're able to describe, then you guys are done with the theoretical part. So don't copy for the sake of copying, but you guys have to write the heading and the diagrams.